Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. Network implementations marks the beginning of one of the most hands-on and technically grounded sections of the Network Plus exam. This domain focuses on understanding how devices behave within a network, how they are deployed, and how different types of equipment contribute to the overall architecture. Implementation refers to the practical side of networking, where theoretical concepts turn into real cables, real ports, and real data movement. It's where infrastructure is not just planned, but actually built, tested, and operated to ensure reliable connectivity. This domain is essential because network implementations directly determine how data travels, how devices communicate, and how performance and security are maintained. Without a sound understanding of how to correctly implement devices, protocols, and configurations, even the best designs will fail to operate effectively. The Network Plus exam reflects this importance through scenarios that simulate actual deployments, configuration interpretation questions, and functional mapping exercises. Mastering these topics will help you both on the exam and in real-world environments where infrastructure stability is non-negotiable. At the heart of Domain 2 is the understanding of how physical and logical devices interact. Physical devices include routers, switches, access points, and firewalls, each with their own interfaces, cables, and connectors. Logical devices include virtualized equivalents, or functional roles like virtual routers, or VLAN in a port. Implementation requires not only plugging in the hardware, but also understanding the logical behaviors, how switches forward based on MAC addresses, or how routers make decisions based on IP. These protocol-based actions are key to controlling traffic flow and ensuring accuracy. Exam coverage in Domain 2 spans a wide range of foundational networking topics. You'll be expected to know device types, such as switches, routers, wireless controllers, and specialized equipment like load balancers. Routing and switching concepts will appear frequently, especially those involving IP behavior, static and dynamic routing, and forwarding logic. You'll also need to know VLAN configurations, trunk port behavior, and how port settings impact traffic direction. Domain 2 links directly to core networking functions and is a heavy focus area on test day. One of the most critical implementation skills is understanding how devices interconnect and communicate. Layer 2 and Layer 3 devices work together in real networks, with Layer 2 focusing on local traffic and Layer 3 handling routing between subnets. Switches use trunks and VLAN tags to pass traffic between segments, and routers interpret these packets to direct them toward their next hop. Implementations must ensure that each device is correctly positioned and that trunking, tagging, and addressing are properly configured to allow devices to reach the correct subnet. Every implementation requires consideration of which OSI layers are in play. At Layer 1, we deal with physical cabling, connectors, and signal types. Layer 2 includes switching decisions, MAC address tables, and port roles. Layer 3 is where IP addresses, subnetting, and routing logic operate. Implementation questions may test your ability to match devices or behaviors to the appropriate layer, especially when troubleshooting connectivity or identifying misconfigurations. Knowing which layer to investigate is a crucial skill for both the exam and the field. It's important to distinguish between implementation and configuration. Implementation refers to the setup and integration of devices in the network, such as choosing where to place switches, which devices connect to which ports, and how subnets are arranged. Configuration includes the software-level tasks like setting IP addresses, applying VLANs, or enabling routing protocols. While the two are closely related, implementation focuses more on the structural and deployment context, while configuration emphasizes the commands and syntax applied after the hardware is in place. Performance and optimization also fall under implementation responsibilities. Devices may be configured to shape bandwidth, prioritize traffic, or increase throughput using techniques like link aggregation. Understanding jumbo frame behavior can help optimize performance for large data transfers. Implementers must consider how multiple devices handle high throughput, avoid bottlenecks, and support quality of service. These concepts help ensure that implementations not only function but do so efficiently delivering the best possible experience for end users. Security concerns must be addressed during implementation, not after. At the port level, administrators can apply controls to prevent unauthorized devices from connecting. VLAN isolation prevents sensitive data from being exposed across broadcast domains. Secure remote access through encrypted protocols ensures that network administration itself remains protected. A poor implementation can open up an organization to attacks, while a secure design helps prevent them from ever occurring. Expect the exam to test your awareness of how implementation directly affects security posture. Understanding the types of questions you may see related to implementation can help focus your study. Scenario-based simulations may ask you to interpret device outputs, choose correct port settings, or analyze VLAN diagrams. Matching questions might require aligning device types with their OSI layer functions. You could also be asked to interpret interface configurations or select the right cabling standard for a given deployment. Familiarity with practical deployment language will help reduce confusion and improve speed during the test. To study effectively for Domain 2, group related topics together. For example, study switches alongside VLAN behavior, or review routers in the context of IP addressing and subnetting. Reinforce protocol behaviors like how ARP functions at Layer 2 or how routing tables determine packet paths. Always tie device functionality back to the layer it operates in, which will help you troubleshoot and understand configuration dependency. Visualizing traffic flow is especially useful. Try mapping how a packet would move from one device to another and identify each step of its journey. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Switches play a foundational role in network implementations, particularly at Layer 2 of the OSI model. Their primary job is to make forwarding decisions based on MAC addresses, sending traffic only to the port where the destination address resides. This behavior reduces unnecessary traffic and improves performance compared to older technologies like hubs. Switches can support basic features such as port speed configuration and auto-negotiation, as well as more advanced functions like port security, VLAN tagging, and link aggregation. Understanding how switches operate is essential for any implementation scenario. Routers serve as the primary devices for Layer 3 connectivity. They define network boundaries by connecting different IP subnets and making path decisions based on destination IP addresses. Routers maintain routing tables, which include entries for directly connected networks and paths learned through static routes or dynamic protocols. Implementation tasks include assigning IP addresses to router interfaces, defining static routes, or enabling protocols like OSPF. Routers play a critical role in ensuring that traffic reaches the correct destination. Beyond local network segments, wireless networking is a key part of modern implementations, and integrating wireless components requires careful planning. Access points act as the bridge between wireless clients and the wired network. These devices transmit and receive radio signals, translating them into Ethernet frames. Wireless LAN controllers manage multiple access points, applying configurations and coordinating security policies. Implementing wireless networks includes selecting channels, adjusting power settings, and ensuring appropriate SSID segmentation. Integration with wired infrastructure often involves VLAN mapping and proper placement of access points for optimal coverage. In addition to general-purpose network devices, implementations often include specialized hardware to support specific functions. Load balancers distribute traffic across multiple servers, improving performance and fault tolerance. Proxies serve as intermediaries for client-server communication, enabling content filtering and caching. VPN gateways establish secure tunnels between remote users or sites and internal networks. Media converters allow different cabling types, like fiber and copper, to interconnect. Understanding these devices' roles enhances your ability to deploy flexible, secure, and scalable networks. Routing technologies and protocols are essential components of any implementation involving Layer 3 communication. Static routing requires manual entry of each route, making it predictable but labor-intensive. Dynamic routing protocols such as OSPF or EIGRP learn routes automatically and adjust to network changes. Administrative distance helps determine which protocols route to trust when multiple options exist. Implementers must understand when to use static versus dynamic routing and how protocols interact within the broader topology. The exam may ask you to interpret a routing table or identify the behavior of a protocol. VLANs are a central concept in logical network segmentation. A VLAN groups devices into the same broadcast domain, regardless of physical location. This enables separation of traffic based on function, department, or security level. For example, voice VLANs carry IP telephony traffic, while data VLANs handle standard workstation traffic. Trunking allows multiple VLANs to pass over a single link between switches, using tagging protocols like IEEE E800 and 2.1Q. Implementers must configure both access and trunk ports correctly to ensure VLAN integrity and maintain isolation between network segments. Ports on network devices serve multiple roles depending on their configuration. Aggregation combines multiple physical ports into a single logical link to increase bandwidth, often referred to as link aggregation or ether channel. Security filtering can be applied at the port level using features like MAC address limits or 802.1x authentication. Port mirroring allows traffic from one port to be copied to another for monitoring purposes, supporting visibility and troubleshooting. Proper port role configuration contributes directly to performance, security, and manageability in network implementations. Wireless implementations require consideration of several factors unique to radio-based communication. Frequencies must be selected to minimize interference, particularly in environments with many overlapping access points. Channels should be assigned to avoid overlap, especially in the 2.4 GHz band, where fewer non-overlapping options exist. Happily, structure must support both user access and administrative control, often involving guest and internal SSIDs with separate VLANs. Antenna types and placements also impact coverage and performance. Topology options include centralized controller models and distributed mesh networks, each suited to different scenarios. Domain 2 of the Network Plus exam brings together foundational concepts and real-world application. You'll need to know how devices function, how they interconnect, and how their configuration affects overall network behavior. Layer-specific responsibilities guide both design and troubleshooting. Mastering implementation topics ensures that you can interpret diagrams, configure systems correctly, and recognize device roles and relationships. This domain links theory with hands-on knowledge and is central to achieving success both on the exam and in network technician roles. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.